Hello, grade 6 students, and welcome back to the physics class. In this video, we are going to differentiate between the different types of potential energies. Before we start, let's review the law of conservation of energy. The law of conservation of energy states that energy is neither created nor destroyed. It is transformed from one form to another. Look at this ball, which stores gravitational potential energy at the top of this inclination. As the ball is moving down, the potential energy decreases due to the decrease in its height. On the other hand, the speed increases because the potential energy is transformed into kinetic energy. Well, another thing to remember is the definition of energy. What is energy? Energy is the ability to do work. In this example, the brown ball is in motion and has kinetic energy. This energy is used to move the blue ball, which was initially at rest, and accordingly, in this case, energy was used to do work. Thermal energy. Look at the screen. You should see water in both the solid and the gas states. Let's describe the motion of the particles in the ice and in water vapor. In which case do you think the particles move faster? It's clear that the particles move faster in water vapor. Thermal energy is the sum of kinetic and potential energies of all the particles, whether they were atoms or molecules. It depends on the number of particles and how fast they are moving, and it depends on how far the particles are from each other. So, which has more thermal energy? 1 cup of ice or 1 cup of boiling water? It's clear that the particles move faster in boiling water and then they have more kinetic energy. The sum of the kinetic energy of all particles will give the boiling water more thermal energy. Now, let me ask you another question. Which has more thermal energy? An iceberg or a cup of hot coffee? If your answer is a cup of hot coffee, this means that you took the speed of particles into consideration, but you ignored the number of particles. It's clear that the number of particles in an iceberg is enormously bigger than the number of particles in a cup of boiling water or in a cup of coffee. The big number of slowly moving particles in an iceberg have more thermal energy than the small number of particles moving fast in a cup of water. Electrical potential energy. Electrical potential energy, which causes the movement of electrons. The lamp at your home is lighting due to the electric current passing through it. Electric current is the flow of electrons which transfer energy to the electric components as the electrons pass through them. Radiant energy. Radiant energy may be in two forms: a visible form, such as light, and invisible form, such as electromagnetic waves used in telecommunication. Light is a kind of wave. How does the sunlight reach the earth? The sunlight reaches the Earth by electromagnetic waves that propagate in vacuum until they reach the surface of the Earth. Similarly, the light energy generated from the lamp will reach our eyes through the propagation of electromagnetic waves. Nowadays, we enormously use cell phones and internet more than any time before. Have you ever asked yourself how this data is transferred from one place to another? Messages, calls, and even videos are transmitted as electromagnetic waves. Sound is also a wave energy that can only propagate through the matter but cannot propagate through the vacuum. Types of potential energies. Potential energy is the energy stored in an object. This stored energy might be due to its vertical height, elasticity, or chemical composition. Let's discover each kind together. Gravitational potential energy. Gravitational potential energy is the energy stored in an object as a result of its vertical height. Gravitational potential energy is calculated through the formula PE equals m multiplied by G multiplied by H. This formula shows clearly that this kind of energy increases as the height increases, and it also increases with the increase of the mass. Elastic potential energy. Elastic potential energy is energy stored as a result of applying a force to deform an elastic object, such as a spring. The energy is stored until the force is removed and the object restores its original shape. The deformation could involve compressing or stretching or twisting an object. This video will visualize the concept clearly.
Elastic potential energy is the energy that is stored in elastic materials and objects such as springs and rubber bands. If we compress a spring, the force we apply to it will be stored in the spring as elastic potential energy. Once we move our hand, the stored energy will be released, helping the spring bounce back and return to its original position. We can observe a similar phenomenon when we stretch the spring. The stored elastic potential energy will help it restore its original position once we release it. A stretched rubber band also acquires elastic potential energy. The further it is stretched, the more potential energy it has. Let's look at a bow and arrow. When the string of the bow is pulled, the bow, which is made of a flexible material, will bend and store energy. Once the string is released, the energy will also be released, launching the arrow. The further back the string is pulled, the more the bow will bend, allowing the arrow to travel even further.
Chemical potential energy. Chemical potential energy is the energy stored in the chemical bonds of a substance. This energy is released when bonds are broken. The various chemicals that make up gasoline contain a large amount of chemical potential energy that is released when the gasoline is burned in a controlled way in the engine of the car. The release of that energy does two things. Some of the chemical potential energy is transformed into work, which is used to move the car. At the same time, some of the potential energy is converted to heat, making the car's engine very hot. The same process will take place in our bodies when chemical energy is released by breaking down food. This energy is used to do work such as moving, running, playing, and it's also used to keep our bodies warm at a fixed temperature that is equal to 37 degrees Celsius.